Hello everyone, let me introduce myself. My name is Christian Dewanga Widihandaru and I'm from Industrial Engineering from class I. And then now I will explain about the take home. There are two questions that's shown. So the first question is about calculate the magnitude of force supported by bearing P. Like this is the P during the application of the 120 Newton meter coupled to the shaft. And then there is also the capacity that hold this plate for not moving. So first things we have to write the coordinate of each point. From the A is 0, the Y is 680, and then the Z is 0, the B it's same as A, but the Y is 480, and then the Z is 0. For the C, X and Y is 0, but the Z is 200 millimeter. And then for D, D has X of 600 millimeter, and then the Y and Z are 0. So for now, I read also the size of the plate. The size of the plate is 600 millimeter times 400 millimeter. And then for the mass of the plate is written with 50 kilogram. The gravity also 9.8 meter per second square. And then from there we can calculate the weight of the plate. So the weight of the plate is basically just mass type gravity. So 50 kilogram times 9.8 meter per second square, and then it becomes 147 Newton. So the thing that we have to know is the weight of the y-axis from P is carried entirely from with bearing A. So P will not have or carry weight from y-axis because A take it. And then from that we have to know the things. And the question is the force supported. The force is, this is the equation for the force is the square root of px squared plus py squared plus pz squared. From that we have to find the moment first. Moment at the point A is mx equal with minus fy times c. Fy is the minus is already minus, and then times 0.2, then it becomes minus 29.4 Newton meter. Because the equation is negative also, it made the moment in x-axis is positive 29.4 Newton meter. And then for the moment in the z-axis, same as the moment of the x, but it's just different range, and then there is no minus in the front. First is minus 147 Newton times 0.3, and then the answer is minus 44.1 Newton meter. That's for the x and z. And then the moment at point B, we now looking for the P. The P is the equation sigma mx equal to 0. So from that we can just insert the thing 29.4 Newton meter plus Pz, and then this is the range 0.2 equal with 0. Pz times 0.2 equal with minus 29.4 Newton meter. Pz is minus 29.4 Newton meter divided by 0.2. So it makes 147 Newton meter. And then for the total moment from Z is 0, because as we know that the moment from Z axis